Welcome to part 2 of the tutorials on CalcLink. In this part I'll be showing how to use CalcLink from the spreadsheet environment. So we launch CalcLink by saying connect in any spreadsheet cell. Then we get a dialog that asks us if we would like to connect to an existing kernel or if we would like to launch a new one. I'll be talking about connecting to an existing kernel later on. For now we launch a new one. Then we have to pick a kernel file. And for this tutorial, we just pick the default. And if it was successful, we get a confirmation and a new window called the control panel, which contains several buttons that can be used to perform routine tasks in CalcLink. Then I would like to point out that the CalcLink functions can be accessed through the wizard. There's a category called add-in, and most CalcLink functions begin with the word eval for evaluate. And a user could now go through the wizard and fill the fields for these evaluation functions. For this tutorial, I'll just use the cells and the push buttons. So we begin by submitting a simple mathematical computation to the kernel. We're just asking it to add two numbers, but given that we can submit any valid mathematical expression, we are not limited to those arithmetic operations. For example, we could assign a number to a variable. In this case, we are assigning the number 555 to var1, and now that it's in the kernel, we can always get it back simply by querying its number, its value. This is also not limited to numeric operations. We can also submit operations that result in strings. For example, this will return a string. Notice that it's flush left, indicating that the computed output was a string. Now, these operations would be quite boring in spreadsheets if everything had to be done cell-wise. So for that reason, Calc supports what is called an array formula. And an array formula works by having the user select the cell range for the output first and then entering the array formula. And CalcLink supports this with the function called eval array. So I've highlighted 16 cells, and the operation I'm having in mind is simply the 4x4 Hilbert matrix. I'm now submitting this to the kernel for evaluation, and I get back the 4x4 Hilbert matrix in the cell range I had selected. Notice that the numbers have been coerced to rationals. The 4x4 Hilbert matrix in Mathematica is of course not rational data, but that way it cannot be represented in a spreadsheet, because all numeric data in a spreadsheet has to be of type integer or rational. So CalcLink coerces this to rational data. Cell ranges can also provide input, not just be used for output. So in the following, I'll be performing a few matrix operations. So I'm creating a matrix with just dummy data that I'm using in the following. The CalcLink function that accepts cell ranges as data is called eval range. So in this example, I want the determinant of this matrix. So I type eval range, then the Mathematica function det. I highlight the cells that I want to be used as input, and I submit for computation, and I get the determinant for this matrix. These cell ranges can be input and output also in the same function. So the Mathematica function, the CalcLink function supporting cell ranges for input and cell ranges for output is eval range array. So for example, now I could compute the eigenvalues for this matrix. I type eval range array of the eigenvalues of my selected matrix, and if I submit it as an array formula, I get the eigenvalues. Similar, I can compute the eigenvectors. I have to highlight a 3x3 cell range, and I submit eval range array with the eigenvectors, highlight the cell range, and submit as an array formula, and I get the normalized eigenvectors. One of the hallmarks of Mathematica is, of course, symbolic computation. So in the following, I show a symbolic computation. We would like to solve a simple linear equation and return the number that is the solution of the linear equation. So for example, we say eval, then the first for the replacement rule, the first of x of solve. As a linear equation, we just pick 3x minus 7 is 4, and we want to solve for x. And we submit this and get the correct numerical solution, 3.66667, for a linear equation that was solved by the Mathematica solve command. Now, given that we can use any Mathematica expression in these computations, I want to show an example that's a bit more complicated. For example, an operation that's involving the Mathematica function map. So I will create some dummy data first. We want to have the first few integers, and we would now like to compute the number of integers from 0 up to that number. So I use eval range with an expression that is a bit more complicated, the sum of k involving map and then copy this formula downward. Notice that this every number here in the G column is the sum of the first n integers up to that number. We don't have to use the function eval range for that. If we don't want to refer to cell ranges, we can also splice individual cells with the concatenation operation in Calc. So we could have achieved the same by saying eval, and now we submit the Mathematica function binomial, and now we have to splice in the cell that we want to refer to. And we would get the same result. Notice that in this case, in every cell, we are referring to a cell in the F column by splicing it in through the concatenation operation. And in this case, we are using eval range to refer to it directly as an argument to the function. And this concludes part 2 of the CalcLink tutorials. Thank you.